Good morning, everyone. Myself Devika. I work as assistant professor in the Department of Electrical and Electronics Engineering at Trinity College Institute of Technology. Today we have discussed about the subject on basic electrical and electronics engineering, which is subject for second semester 2025 regulation. Today I am going to present about single phase induction motors, which comes under basic electrical and electronics engineering. These motors are very commonly used in our day-to-day life. Introduction. Single-phase induction motors operate on single-phase AC supply. They are most familiar motors because they are widely used in homes, shops, and offices. Although they are less efficient than three-phase motors. So three-phase supply is not available in most residential areas. Since early power systems were designed mainly for lighting, single-phase supply became a common, which led to the development of single-phase motors. Types of single-phase motors. The application of single-phase motors are commonly used in fans, refrigerators, washing machines, mixers, and blenders, small pumps. They are mostly used for low power applications. Types of single-phase induction motors are generally usually built in the fractional horsepower range and are classified into three main categories: single-phase induction motors, single-phase synchronous motors, commutator type motors. In single-phase induction motors is classified into split-phase type, capacitor type, and shaded pole type. Uh, then single-phase other types of single-phase motors, single-phase synchronous motors include reluctance motors, hysteresis motors. Next, commutator type motors include repulsion motors, repulsion start induction run motor, universal motor. Construction of single-phase induction motor. So it consists of stator and rotor. You know that stator with a single-phase distributed winding, and the rotor squirrel cage rotor. When connected to a single-phase AC supply, the motor does not develop starting torque. So why a single-phase induction motor is not self-starting? That means when a single-phase supply is given to the stator, it produces a pulsating magnetic field, not a rotating magnetic field. Therefore, the motor cannot start by itself. However, if the rotor is given on initial rotation by some external means, the motor will continue to run. Double field revolving theory. This strange behavior of single-phase induction motors is explained by the double field revolving theory. According to this theory, the pulsating field can be resolved into one forward rotating field, one backward rotating field. At standstill, both fields produce equal torque in opposite directions, resulting in zero net starting torque. Next, making single-phase induction motor self-starting. So to make the motor self-starting, we must create a rotating magnetic field. So this rotating magnetic field is achieved by using additional winding and converting single-phase supply into two-phase supply. Once the motor reaches sufficient speed, the starting winding can be disconnected. Classification based on starting method. Based on the method used to make them start rotating, self-starting, single-phase induction motors are classified as split-phase motors, capacitor motors, shaded pole motors. Split-phase induction motor construction. In this motor, it has two components. You know that the stator and rotor. In this motor, the stator has two windings. One is main or running winding, then auxiliary or starting winding. The starting winding is placed 90-degree electrical from the main winding and is used only during starting purpose only. Design of windings. So the two windings are designed differently. Starting winding has higher resistance and low reactance. Main winding has low resistance and high reactance. This design helps in creating a phase difference between the currents. So the motors will be the operation of split phase induction motor. When supply is given, main winding carries current IM. So starting current carries current IS. Due to different impedance, a phase difference of about 25 degree or to 30 degree is produced, creating a weak rotating magnetic field that starts the motor. Disconnection of starting winding. When the motor reaches about 75% of synchronous speed, the centrifugal switch disconnects the starting winding. After that, the motor will be continued to run as a single phase induction motor. So this starting winding is only for to run the motor's starting purpose only. Characteristics of single phase induction motors include a low cost and widely used, almost a constant speed motor. Speed variation is only 2 to 5%. Moderate starting torque only. Power rating is usually 60 watt to 250 watt. Then application of split phase induction motor. These motors are commonly used in fans, washing machines, oil burners, small machine tools. They are suitable where starting is infrequent. Then torque and speed characteristics shows zero torque at a standstill. Torque increases after starting, maximum torque below the synchronous speed. So the motor always runs at a speed slightly less than the synchronous speed. So the slip speed is means the difference between these two speeds, synchronous speed and rotor speed. Conclusion. To conclude, we have discussed an introduction to single phase induction motors, types of single phase motors, need for starting methods, construction and operation of split phase induction motor. These motors play a very important role in domestic and commercial applications. Thank you.